Our daily prompt today is construction of iconic buildings. You can find all the prompts detailed at the bottom of the video description. All the images you will see in this video were created using the prompts on the list. Today, we're dressed up in the topic construction of iconic buildings as we guide the AI to generate images of these iconic buildings. We've given it specific instructions to make the images a close-up shot with shiny chrome art, 3D rendered, cinematic, vibrant, and at a resolution of 32K with SE200. How the specific settings affect the generated images. The settings we chose directly influence the end results. Close-up shot brings us right into the minute architectural details. Shiny chrome art imbues the structures with a futuristic touch. 3D render adds dimensions and depth, while cinematic lends a theatrical mood to the buildings. Vibrant ensures lively colors, and 32K provides unprecedented detail. You can find all the prompts in the video description below, promising you an extraordinary visual experience today, along with some jokes about construction workers. Let's delve deep into the fascinating history and unique construction challenges that make each of these iconic buildings so special. The Statue of Liberty. When France gifted the Statue of Liberty to the United States in 1886, it was more than just a symbol of friendship and freedom. It was an engineering marvel. The copper statue was disassembled into 350 pieces and packed in 214 crates for its journey across the Atlantic. Reassembling it was a monumental task, one that relied heavily on the skeletal structure designed by Gustave Eiffel, the man behind the Eiffel Tower. The challenges did not stop at mere construction. Public opinion was sharply divided, as many considered the $102,000, about $2.5 million today, required for the statue's pedestal to be extravagant. Despite the challenges and opposition, Lady Liberty stands tall, welcoming immigrants to the land of freedom. The Eiffel Tower. When it was first proposed, many Parisians labeled the Eiffel Tower an eyesore and a useless structure. The Iron Lattice Tower, however, was anything but useless. It showcased groundbreaking advancements in metallurgy and civil engineering and also served as a radio tower. The tower's 18,038 individual iron pieces were assembled with 2.5 million rivets. Facing public outrage, the persistence of Gustave Eiffel ensured the tower's completion in 1889, and it remains one of the world's most visited tourist attractions. The Pyramids. The pyramids of Egypt are ancient yet everlasting. Built to serve as monumental tombs for pharaohs and their consorts, the construction methods remain the subject of debate and speculation. Theories range from slave labor to alien intervention. The most credible theory, however, involves a skilled labor force using sleds, rollers, and sheer manpower to move massive stone blocks into position. Opposition to their construction? Virtually none. In a society where the pharaoh was considered a god, his decisions were beyond questioning. Sydney Opera House, Jorn Utzon's modernist masterpiece, faced enormous technical challenges, primarily due to its unique sail-like roofs. Engineers had to devise new methods to construct these forms, involving precast rib segments. Acoustic engineers also faced difficulties ensuring the sound quality matched the grandeur of the structure. Budget overruns and public skepticism plagued the project, but today it is a symbol of Australia's artistic and engineering prowess. Burj Khalifa towering at 828 meters, the Burj Khalifa holds the title of the tallest structure in the world. The primary engineering challenges included creating a foundation capable of supporting such a colossal structure and designing it to withstand Dubai's intense wind and seismic activity. Interestingly, there was minimal public opposition, largely because the building was seen as a symbol of Dubai's rising status on the world stage. Great Wall of China. Unlike most other structures on this list, the Great Wall was built over several dynasties and centuries. The primary engineering challenge was less about technology and more about logistics and labor. Opposition to its construction was silenced through force, and many laborers who died during construction were buried within the wall itself. Taj Mahal, built as a mausoleum for Emperor Shah Jahan's wife, Mumtaz Mahal, the Taj Mahal is an example of Mughal architecture combined with Persian and Islamic elements. The primary challenges involved intricate marble carvings, the precision of the inlaid gemstones, and the structural integrity required for the massive dome. Opposition was mostly of a financial nature, considering the empire's wealth was heavily used for the construction. Petronas Towers. In Kuala Lumpur, the Petronas Towers were designed to symbolize Malaysia's growing technological prowess. They were the tallest buildings in the world from 1998 until 2004 and were designed to incorporate Islamic architectural elements. The major challenge was the deep foundations required due to the soft soil in the area. Christ the Redeemer built atop the Corcovado Mountain in Rio de Janeiro. This iconic statue required materials to be carried up a mountain by a cogwheel train. It had to be resistant to high winds and the elements, not to mention the wear and tear from thousands of tourists. Opposition was mostly based on the project's religious nature in an increasingly secular society. Empire State Building. At the time of its construction, it was the tallest building in the world. Built amid the Great Depression, its rapid construction served as a symbol of American resilience. The engineering challenge involved its sheer height and the need to build quickly. Opposition was primarily due to safety concerns, both for workers and the public. Guggenheim Museum, Bilbao. Designed by architect Frank Gehry, this building revolutionized the way architects and people think about museums. The deconstructivist style was a nightmare for engineers, involving customized software for the building's construction. The public initially opposed it, doubting its utility and aesthetic value. Sagrada Familia. Still under construction after over a century, the Sagrada Familia in Barcelona has adapted modern construction techniques while maintaining Antoni Gaudi's original vision. Opposition has mainly come from those who believe the ongoing construction diverges too much from Gaudi's plans. Leaning Tower of Pisa. This tower was never meant to lean. Built on unstable subsoil, it began to tilt during its construction in the 12th century. Engineering interventions have managed to partially correct the lean, but it remains a cautionary tale in foundation engineering. A few construction jokes. Why did the construction worker bring string to the bar? To tie one on. Why did the scarecrow become a successful builder? Because he was outstanding in his field. Why did the bricklayer refuse to work with his brother? Because he was a blockhead. Why did the architect go to therapy? He had too many complexes. Why was the math book perfect for the construction job? Because it had all the right angles. Why did the engineer go broke? Because he kept burning bridges. If you found today's deep dive into the construction of iconic buildings as fascinating as we did, hit that like button, share this video with your friends, and subscribe to our channel. Stay tuned for more incredible insights into this innovative field. You too could create captivating visuals as only a few can.